Hello, welcome to this workshop on basic road design by AutoCAD Civil3D. This video is specially prepared for the civil engineering undergraduate students of King Fahd University in Saudi Arabia to help accomplish their course project. But in general, anybody who is interested in road design by Civil3D, he might find this video very useful. So at the beginning, I will introduce you to the Civil3D user interface. Then I'll show you how to create points and point groups, and out of those point groups, how you will create your new surface, and followed by creation of horizontal alignment, and then creating your profile and cross section, that is your vertical alignment, and finally I'll show you how to create corridors. At the very end, I will show you how to create reports, for example volume reports, volume calculation, and mass flow diagram that you might need to include it in your report. Before we start, we need to have the design criteria. Here you'll see that the design speed is taken as 80 km/h. The maximum grade is taken 6%. Lane width would be 3.6, whereas the shoulder is 2 meters in width, and the Emax is 8%. Before you start, you also required to download these two files. We will need these two files where we will create our corridor. If you already do not have AutoCAD Civil3D in your computer, you might download it from this given link and then activate your software using the serial key, and click on the desktop icon to start the AutoCAD Civil3D. Make sure that you start with the metric one, and the figure below is the first user interface of your Civil3D. So this is your user interface, where you have the main ribbon here. This is the main ribbon, and if you do not have this tool space showing up, what you can do, you can just toggle on and off from here. So you can reproduce it if it is not there. And at the same time, you should also make this menu bar visible. So if it is like this, click on show menu bar. Here it is. You have this menu bar. Now, first of all, save your file. Click save. This dialog box will pop up and show him where you want to save your work. I prefer to save it in my desktop. Let's create a new folder, and here I will name it as Civil3D workshop. Now you need to go in the drawing utilities, drawing settings. You need to do some settings there. Make sure this is in meter, degrees, scale, any scale that you prefer. I'm fine with it. Now no datum has been selected, so I will select Saudi Arabia from this drop down list. Saudi Arabia. There you will find all the zones available in Saudi Arabia. Where I am now, the zone in the new system is I think zone number 39, but it's not showing up here. So let's take the closest zone that we have it here, Bahrain. Apply, Okay, so we will now start with points. Here we have points in prospector. Right click, create. This point creation toolbox will open. Then you have import points here at the very last. Click, add a file where you have your points. I have it here in my import points. I have it in my D drive. Okay, let's go here in D drive. Not here exactly. Active here. Go to D Civil3D videos. Here we have our CSV file, comma separate file. Open it. It has opened. Now I have opened that CSV file separately in Excel. You could see that the first column, it represents the easting, then northing, and that is Z, that is the elevation. So from this option I will select this one, E and Z, easting, northing, and the elevation, comma delimited, and press OK. Now press Z for zoom, enter, and then E for extend, enter. Now you can see the points. Here the points, there is no leveling. You may want to level those points. Let's see how we can level those points. Okay, now we'll go to point groups, right click, properties, find all points. We have all points. Press OK, click on the plus sign. You have all points. Right click, properties. Here you have the point style, which is basic. Now I'm happy with it. Point level style, here none is selected. Now you can choose any option that you may need. I'll choose this elevation only, so select it, apply. I will not go to the other options that I have from this box. Okay, now we see that you have the elevation of all of those points. Now again, you may not want to see these markers and labels. Anytime you can just switch it off, on and off. To do that, you go to point groups, again all point, properties, from the point style, click here. You have the display here, so you can just switch on and off from this bulb. This is off, and that will put it to on again. So let's switch this off for this moment. Apply, okay, apply, okay. Okay, now I have the markers on again. Now we will create our surface out of these point groups. So what we will do, we can go to surface here, or here, they are the same, create surface. So create surface, thin surface, C topo is okay, fine. Press OK. You see there is, now we have a plus sign, so we have a surface already created. Okay. Then go to definition, point groups, right click, add, apply, select all points, apply. Okay, now we have your surface created for you using all those point groups. Now you may want to see your your contour lines a little bit more denser. To do that, I'll go to surface again, surface, right click, edit surface style. Here you have the contour interval showing major and minor 2 and major 2. Let's make it 0.5, so it will automatically change to 2.5 as the ratio was 2:10. Apply. Okay, yeah, now we have your contours a little bit more denser. Now you may want to label these contours. To do that, select it first. This ribbon will show up. Go to add labels, then contour, the last one, contour multiple at interval. Select it. It asks you for to show him the first point. Let's pick it here. Make sure that your object snap is switched on. Select it here, maybe select there. It's asking for the interval, which is 100 by default. I'm happy with it. I'll press enter. So it's working on the background. Yeah, now you see that these contours have been labeled based on the elevation. You can keep on doing this for the other contours. Same thing I'll do. I'll just select this one, add labels, select it here, other points, same thing. We have it here, we have it here, maybe a few here are missing, so let's draw a line diagonal to these. Same thing, add labels, select it here, select it there. Okay, now I'm happy with it. Let us switch off all these point markers. Go to point groups, all points, right click, properties, click here, switch it off, apply, okay, apply, okay. Now you have only your surface with the contours. So that is how you create contours and a thin surface, triangular, irregular network surface using the surveying data. Now a while ago I have just shown you how to create surface from surveying data, but for your project actually there is a ready-made contour file where the starting point and the end point for each group is already mentioned. So let us work with that specific file, and we will work on our project on that specific contour file. To import that file, go to insert. In the insert ribbon you have this block panel, and from this block you press enter, insert, more options, browse for your file. I have it in my D drive. here I have this point, I have this file open. Make sure this explode is ticked in, and I also prefer to have this option ticked in, which is specified on the screen where I will put my contour. Everything is fine, looks fine. Let's press OK. Click on the screen. Nothing is showing up. Let's do the same thing again. Zoom. It's still working. Yeah. Now for the demonstration purpose, maybe we can choose one pair of these 11 groups. Let's choose A2 and B2, okay, as our workspace. Meanwhile, what we can do, this contour is actually too long. I think it's altogether 35 kilometer long, so we will not need all of it for our demonstration purpose. So maybe what we can do, we can just chop it off to only those parts that we need and delete the redundant part. To delete it, just select like this and press delete. 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 You can also delete that part. So I'm fine with it. So that is the contour space where I will be working. Okay, now there are a few things that you have to do before we proceed. We can just freeze some of these layers. So here I'll click it here in the layers panel, click it here. Okay, this is freezed. We can also freeze the yellow layer too. Right click, enter. Let's go to layer properties. Okay, let's see first those two layers that we have just freezed. These are the two layers that we have freezed, and you could see there is another layer which is freezed by default, this one. So unfreeze this layer, close it. Let's redo it again. I think there was some problem. Freeze this one, enter, keep this the red one on, here, this one, just unfreeze this one. Okay, select this one option. Yeah, it has created, actually it has created the whole surface. It doesn't matter, you may want to unfreeze this layer as well. It's frozen now, it will not be visible. You have your A1, A2, A3, that is the first three groups. Okay. Also, you can just rebuild this surface. Can do one more thing. Surface properties. This looks fine, this looks fine. Apply, okay. Okay, now here you have your new surface with the starting and ending point for three of these groups. As I told you, I will select A2 and B2 as my starting point and the end point. If you want to change the name of it, this XGR, right click, surface properties, give it a name, let's make it EGL, existing ground level. Okay, now we will draw our horizontal alignment. To do that, go to alignment, alignment creation tool, give it a name, fine, this is okay, proposed. Let's go to design criteria, let's change it. If you remember that we had the design speed 80. Okay, change this one. To change this one, you have to click here, select 8 for the Emacs. Okay, rest of the things looks fine. Press OK. This toolbox will open. Drag this toolbar to somewhere in the corner so that you can see this view. Okay, now from here, draw tangent with curves, select this one. We will select tangent with curves, select it. Now you will draw your alignment. And for this part of the road, maybe we can have at least 3 to 4 horizontal curves. So let's start from here. While you draw the horizontal alignment, you must abide by the rule that if you go parallel to the contour lines, you will minimize the cut and fill that is required for the construction of the road. So let's get one horizontal alignment here, one there, maybe one here, one here, and finally the ending point. Right click. Now you see that your horizontal alignment, or the initial road has been created with the stations labeled at a distance of 20 meters from each other. Now if you want to change the station interval, simply just click on it, then right click, go to edit alignment labels. Here we have the major station and minor station. Let's make the major stations at an interval of 100 meters apart and the minor to be 25 meters. Okay, I'm happy with the rest of the things. Apply. Okay, now let's check. Yeah, these are the minor stations and this is the major station. We have 100, started at 100 and 200, so I'm fine with it. Now if you wish to have the curves more flatter, then you can also change the radius. To do that, go to this alignment grid view, click here. It will show you all the curves that you have, and these are the radius. By default it has taken 229. You may want to change it. Let's change few of those. The first one, this is the first one, let's change it to 400. Yeah, this is dynamic, so it has changed, it has gone more flatter. Let's make it 300. Yeah, let's make it more flatter, 350. For this one, okay, 300 again. Yeah, the curves are now more flatter. Okay, here it is showing some, there might be some problem in it. Let's see which one is this. Is it this one? Let's change it again. Yep, looks fine. So close it. Everything looks fine with the horizontal alignment. This is your PI. It's the point where the curves has started, and this is the point where the curve has ended. Okay, I'm happy with it, so let's proceed to profile creation. And to do that, just first of all close this dialog box. Okay, to create profile, go to profile, then create surface profile. This is selected, add this one, and click here, draw in profile view. Okay, you can give it a name or leave as it is. Station range. Okay, profile height, this looks fine. Display options, data bands. Okay, everything looks fine. Now click on the create profile view here, and in any empty space just click on the screen, this looks too dense, so dense that you cannot even see the vertical existing ground. So what we can do to, yeah, here it is showing up. What we can do to see it properly, select this one first, right click, edit, profile view style, go to grid, check this too. Okay, click the highest profile. Okay, then go to horizontal axis. You may want to change it, the major ticks and the minor ticks. Let's change it to 25, that one 25 as well. The vertical axis, uh, 5. Let's make it 5 as well. We can change it back anytime we want. Other things looks fine. Twenty-five, apply. Okay, yeah, now we have a better picture. There are the stations and there are the elevation. Maybe we can change it a little bit. Again, go to profile, edit profile view, right click, and then go here. Let's see how it looks like. 10 and 5. Here's your elevation. This is the name that was given. These are the stations. Okay, now I'm fine with it. Let's change it a little bit more, I think. Yeah, select this one, right click, same, yeah, change it to 50. So there, 50, apply. Looks fine. Now it's okay. We check the stationing. Yes, 50 is the interval. Okay, now it looks quite clear, clean and clear. It will help us to draw our own vertical alignment. Okay, to draw your own profile, go to profile creation tool, select anywhere, give it a name, just make it design. Check this one on. Rest of the things are fine. It's okay. This dialog will, this toolbox will open. Let's move it to a different place. Okay, now go to this first option, draw tangent without curves. Here go to curve settings. This is the crest curve, that is the sag curve. For the crest and sag curve, let's change the length to 300, say, for example 300 here. Also you can also do it by k, this k value. K is, the k is the rate of vertical curvature, where k is equal to L over A. L is the length of the curve and A is the algebraic difference in the intersection grades. So let's go back to length again. 300, fine, looks fine. Parabolic, the major difference between between the horizontal curve and the vertical curve is that the vertical curves are parabolic, whereas in the horizontal curve it's not parabolic. Press OK. Now click here again, draw tangent with curves. Click here, choose the first point, make sure your object snap is switched on. Anytime you can switch it on and off using the hotkey F3. Okay, so here we will have at least two more than two crest curves. I doubt if there is any sag curve or not. Let's try. We will try to go close to the existing ground that we have it here. The red line, it represents the existing ground. Start it here. Let me just switch off the object snap. Click over here. Maybe somewhere here. You already have a notification. Yep, maybe it is not satisfying the curve radius or the length. And finally switch on the object snap. Yes, I'm done. Here you have your PVI and the other stuffs, just giving you the stationing and everything. Now this warning sign appears. How we can change it, how we can remove it? To do that, we have to do it by this table. The K value, there is a warning for the K value. This is, all of these are crest curves. There is the curve length, there's the K value. You have warning for the side distance. Here is the radius. Let's check with the radius first. This is editable, 300, 3000. Still we have the warning, 3500. Okay, doesn't make any difference. Let's change the other one to 3000 as well. We can also play with the K value. Yeah, it's going more than the value that is acceptable by the software. Let's change it to 375. Still we have these issues. Let's see if we can change it manually. It has been removed. No, not yet. Yeah, this is basically for the side distance, and here this is a sag curve, where you know that for the sag curve side distance depends on the headlight of your car. Let's move it a little bit. Gone. Yes, it is gone. Let's flatten this one a little bit here. Cannot go that up because it will make too much cut and fill. Let's see if we can just put it down there. Doesn't look very good. This fortunately we have no issues here. This looks fine. Put this one. Yeah, looks like it's gone. Looks fine now, much flatter. Remaining with only this one. Looks like for this one we need to have a very big cut section here. Let's try to reduce it to here. Still we have it. Or yeah, now it has been gone. Here is your PVI, but in that process actually you'll have more cuts here. But the good thing about design is that there is nothing called wrong in design. So maybe you can also trial and error, do the trial and error, and in several iterative steps you can find out the best path that reduces the maximum cut and fill. So for the sake of this demonstration, I find this is okay. Let's go ahead. Okay, now to create assembly, we will click on this assembly icon. You can also do it from here. Click here, create assembly, give it a name. Rest of the things are fine. Basic. Okay, all codes. Click OK. Click anywhere on the screen. Here you have the median line. Okay, now you need to activate the palette tool. To bring the palette tool, you just simply press the hotkey Control 3. Here you have your palette tool. Now first of all, go to lens, select lens super elevation AOR, click over it. Now scroll down and change it to, okay, it's already there 3.6, so we keep it as the same. Rest of the things you can change these depths based on your criteria that is or design. Other things looks fine. The side right is pre-selected. We keep as it is. Okay, looks fine. Now click on this red line. Here you have your first lane. Now this was a at the very beginning in the design criteria, it was mentioned that you have to design a rural road. So 2-lane rural road with a shoulder would be nice enough. So since this is only for demonstration, I will go only with the simple and basic assemblies you can do, or if you're interested to do more, maybe you can browse for other options, but for the time being let's make only one lane each direction. Right click, enter. Okay, now we will go to the shoulder. Select shoulder, extend all. Come here, change the shoulder width to 2 as it was mentioned. Right is okay, fine. Now here zoom in, and you see there are the circles. This circle actually represents this point, that circle for that point, that circle for that point. I want to use the top corner of our road or lane, so I will click on the circle. Now you have your shoulder. Right click, enter. Okay, now for the side slope, let's go to daylight. For the daylight, click the daylight general. Everything is fine. I'll select it here. Okay, the text looks too big. You can reduce the size of it by using this scale. $500, even less, 250. Looks fine. That was a basic 2-lane, both direction rural road. For a urban road, you may need the curbs, sidewalks, and things like that. These urban sidewalks, these are also possible to design here, but for the sake of simplicity, let's go with it. Now you have to select this daylight. shoulder and length. Then go to home, mirror. Let's check. Okay. Again, it hasn't mirrored yet. Select it, mirror it from here. Now we have it. Okay, that's our assembly. Close this one. This is the cross section of your road. There is a daylight, that is the cotton field slope. This is your shoulder, 2 lanes in 2 direction. Looks fine. Okay, now we will calculate the super elevation for this alignment. So select this one first with left click, then right click, then edit super elevation. Calculate super elevation now. Okay, yeah, you have to choose this one, undivided crown. There are other options as well. The lens, from the lens, change the lane width to 3.6. Shoulder +2. Okay, attainment, skip the default. I'm happy with it. Finish. Here you have your super elevation table. It has created all the information needed for the super elevation. You can create this report later on to be included in your report. So this, for the time being, let's close it off. Okay, now we will create our corridor. So to create corridor, from your home ribbon and create design panel, click corridor, give it a name. Let's change it to design. Okay, alignment is alignment design. Okay, assembly, the assembly that we have just created, and the target surface would be the existing ground level. Okay, press, everything is fine. Let's see the corridor style. Okay, cancel. Okay, now from here, looks fine. Go to set all frequencies. You can change these numbers. Alignment along the curve. We do not have spirals. Curve increment, let's make it 25. Let's make it 25 as well. Change it to 25. Okay, apply, rebuild the corridor. It's working on the background, and press OK. So now you have created your corridor. This is your median line, that is your your lane, that is your shoulder, and that is the daylight. Okay, looks fine. Let's see how it looks along the curve. You could see the cut and fill sections. Okay, now from this active drawing view panel, go to corridor design, select this one, right click, properties, fine, code, feature line, surfaces. Okay, from the surface, click over here, which is create a corridor surface. Okay, now specify code from here, just select the datum, add it, the boundaries, design, right click, add automatically, daylight, looks fine, slope patterns is okay, boundaries okay, apply, rebuild the corridor. Apply. Okay, yeah, you see now the daylight has been added here in that corridor, so we have all the information here now. Now the most important thing is to define sample lines and get the cross section of your corridor. Before we go to sample lines, we also want to see from the object viewer that everything is fine. Select this one and go to right click and go to object viewer, and you can see your corridor. Looks fine. Okay, everything is fine. I'm happy with it. Close it. Okay, now to create the sample line, go to your home panel, home ribbon, then here you'll find the sample lines. Click on it, then press enter. Alignment 1, okay, everything is fine. From this box, uncheck this one. This should be existing ground. That one should also be existing ground. Okay, looks fine. Press OK. Now this sample line toolbox will open. Go to this method, sample line creation method, by ranges of station. Select by ranges of station. Okay, now here in the swath width, you can change this one, or if you're happy with 20, this is actually the width of the cross section. I think 20 is good enough, so we can keep the same. And for the additional sample controls, let's make everything true and true. Press OK. Now in this corridor, you see that the sample line, we have the sample line. For this one, I think 20 would be too close, so let's change this one. The increment, the sampling increment, let's change it to 50. 50. Do not have spirals, but still let's change it to 50. Looks fine. Okay. Okay, now press enter. Now you have all of your sample lines. This is okay. Looks fine. Now to see the section views, go to sections. Create multiple section views. You can give it a name or leave as it is. Varies section placement is fine. Offset range is okay. This is also okay. Okay, now for the EGL, yeah, change it to existing level. It's already existing level. And for the design, this one, change it to finish level. Okay, go to data bands, select band set only for the major station offset and elevations. Looks fine. Create section view, go into a empty space, click. It's working on the background. It has not created properly. Let's try to redo this again. Section, create multiple section view. Oh, here we had a mistake. You have to click on the draft. Okay, elevation range. This would be your existing ground. Finish ground. Data band. Create section view. Working on the background. Yeah, now the section has been created. With the cut and fill. That is your road, that is the ground. So this is the cut amount. Looks fine. Now click on any sample view. Let's go to the menu bar. actually you have to click on the whole of a sample view, not only the road. Yep. Okay, now it has created a new one for this section. Yeah, click here, add this one, apply, and okay. It's working on the background. Yeah, stopped working. Yes, now we have your road cross section here. Okay, that ends our sample line creation section. Now we will compute the material. Go to sections, compute materials, alignment 1 6, and line group, the one that we have it here on the option. Click OK. Now from the quantity takeoff criteria, use this option, earthwork. For the existing ground, select EGL. For the data, select this one, the other option. This looks fine. Okay, so it has computed the material. Later on we will create the report. Next thing is to create the mass hall diagram. To do that, go to sections, we have create mass hall diagram, click on it. You can give it a name if you wish. The material list that we have, total volume, yeah, fine with it. I'll create the diagram now. Click on the screen. Here you have your mass hall diagram. This looks so tensed. Maybe we can change the style of it. Select this one, right click, edit mass hall view style. Let's change it to 10,000. Okay, great. Click this one, looks fine. Display summary, apply. Okay, yeah, much better now. So that is your mass hall diagram. You may want to add it to your project report. Now to insert the volume table, go to sections again, add tables, total volume, cut and fill, one. Okay, looks fine. Click on the screen. Here you have your total volume table. The fill volume, the cut volume, according to the stations, starting from 00 and ending at 6170. So you can have all the information here of cut and fill volumes. Yeah, the cumulative fill volume and cumulative cut volume as well. Here's the final one for the cumulative cut and fill volume. Now if you wish to transfer this volume table in an Excel or some other data spreadsheets, then you have to go to toolbox, click on the plus sign. From the corridor you can create the volume reports. Select this one, right click, execute. Create report. Okay, the volume report has been created in HTML. That is your mass hall diagram. I can select all of it. As much as you need, then copy it, go to Excel, paste it. Yeah, here you have all the volumes and everything. You can also go back to your drawing. You can also get the reports by this station elevation. Create report. Okay, it's creating the report. Station, this thing, nothing. These are the elevation data. So there are several reports. Depending on your need and requirement, you can create the reports. So with this one, it concludes my video, and what I have shown here is only the basic of designing a road using the Civil3D. If you are interested to have more expertise in it, maybe you can watch out for some other available videos in the internet. So thank you, hope you have enjoyed it. Thank you.